Welcome back, engineers. We have been discussing architectural styles, and in this video let's apply a theory to a concept and we'll see how we can actually decide on a particular architectural style. Okay, I hope you're ready. Let's get started. So for this one, we're going to take an example of an e-commerce application scope and we're going to derive the architectural styles for it. And the end goal is what you're looking at right now: user quanta, product quanta, order quanta, delivery quanta, notification quanta, against which we have the respective identified architectural styles: service based, microservice plus event driven, and a couple of microservices. So how did I come to this conclusion that we are going to use these type of architectural styles? For that, we're going to have to go to the beginning of this whole exercise, and we're going to start at the scope first, right? Let's say this is the scope that have been given to us, e-commerce scope. We're going to allow registration and login to customers. Customers can view and browse products. Customers can make payment and place orders. Customers can track the status of their orders. Customers can provide review and share feedback on any particular item or order, right? So this is the high level scope that has been given to us. Generally, in any customer situation as well, the scope would be something similar. There will just be a few bullet points here and there. Maybe a little more detail is added depending on the availability of the customer and the availability of the product scope itself, right? Sometimes the scope itself is not very clear. Sometimes the scope is little bit more clear. Either way, it is up to us as system designers to derive a scope and then provide an architecture for it. So the process that I'm going to show you in this video, it's probably something that is not shown or discussed in any of the YouTube channels, at least the ones that I've not seen so far, unless of course you're following the author himself, Mark Richards, and you are following Software Architecture Monday. You probably already are familiar with this approach, but this is directly from the book that has been written by this author, Mark Richards and Neal in Fundamentals of System Architecture, and that is the approach we're going to follow today. Given this scope, we're going to derive an architecture. We're going to finally arrive at an architectural style for different quantas, right? So let's see how this goes. Let's say we're given a scope like this for an e-commerce application, and our job as system designers is to create architecture for this. So what we're going to do is we're going to do some implicit analysis and we're going to do some explicit analysis. Some requirements are explicitly given, like user needs to register, log in, view and browse products and so on. But there are some implicit characteristics that need to be derived by the system designer himself or herself about, let's say, how should be the availability, or how should be the security, about how should be the performance of the system and so on, right? So for that, let's try to derive some functional requirements first, and then we'll see how we can apply non-functional characteristics to it. So first, we're going to do an activity called actors and actions. In this activity, we're going to derive who will be the actors to our application and what will be the actions that they will actually be performing, right? So let's say there is an actor called customer. Customer will follow a typical flow like this: registers, customer will log in, customer will browse products, add a couple of products to cart, make payment and place order. This can be thought of as the main workflow of the customer. And another flow can be customer logs in, view order details, and from here on customer can track status of an order or leave a review for any particular order as well, right? Let's say these are the flows of my customer. Now let's say there is another actor called product admin. Product admin will be onboarded by some super admin in the company, and product admin will log in. Product admin can do different types of CRUD operations on products: view products, add product, update product, and delete product. Optionally, if you want to provide any approval workflow on top of products, we can add another user called approver or supervisor who will take care of approval flow as well, right? For now, we'll keep it simple. We'll call it as product admin. And then we have warehouse admin. Warehouse admin again onboarded by some super admin. Warehouse admin logs in. Warehouse admin can add stock or update stock, right? So whenever some new stock comes into the warehouse, those details can be updated into the system, right? And then what do we do with the stock? Whenever a super warehouse admin receives an order, the order is validated, the stock is validated, and shipment is created, and the product is dispatched, right? So this is the dispatch side of things, which is also taken care by warehouse admin. And then we have a super admin who will take care of managing product admins and warehouse admins. So these are simple CRUD operations for managing different types of users, right? Customers can register by themselves, so we don't need super admin managing customers anyway. Okay, let's say those are our key users and key actions in the system. So for this, you can keep on adding more users and actions, but I wanted to keep it simple for this video so that we can actually practice how to derive architectural style. So these are my main actors: super admin, warehouse admin, product admin, and customer, right? So those are the main actors and their actions. So the next step we're going to perform is something called as event storming. So we're going to try to identify all the events that are happening within our system, starting with super admin. Let's say super admin is here, onboard a product admin is the activity, and then product admin onboarded is the event, right? So for this event, if there are any sub events, those can be captured here as well, right? Similarly, super admin will onboard a warehouse admin onboarded is the event. Okay, so product admin can do these activities: add product, update product, delete product, and these are the events corresponding to them: product added, product updated, product deleted. So these events can trigger some other events, which can trigger some other events, right? And customer is adding a product to cart, which means product added to cart is an event. Customer is making a payment. Here there are two scenarios: payment can be successful, payment can be a failure. So if payment is successful, a place order activity is performed, which is triggering notify warehouse admin as another activity. So one event can trigger several sub workflows as well, right? And then customer can add a review, and then the event is called new review added, right? So these are some of the events in the system, and these are some things that the system itself is performing. System as a user is performing these things, right? So we saw that product admin onboarded is an event that we saw earlier, and when the system receives this event, it will send out an email to, let's say, a product admin to give them onboarding instructions and so on, right? So this is taken care of a system. So in this case, system is a non-human user, basically some kind of a message queue or some kind of a listener that will trigger some method or some function depending on the event type, right? And then we have warehouse admin onboarded, which will trigger a similar event of sending an email to the warehouse admin, probably with some onboarding instructions as well, right? And then we have these events: product added, updated, deleted. So these needs to be notified to the warehouse admin, that will be taken care by the system. And then update inventory is also something that will happen whenever there's a new product added or removed. Okay, and then we have product added to cart. For this, we can implement it in such a way that we are holding inventory for some time until the product has been removed from cart, or maybe there is some expiry before which user needs to complete the purchase and so on, right? So we can hold the inventory in this situation. And then we had two events for payment. Whenever there's a payment success, we can place the order, update inventory, notify warehouse admin. This can be done by the system user. When there is a payment failure, we'll release the inventory and we'll notify the customer about the payment failure, right? Again, simple events that I've captured so that we can practice how to derive architecture styles. And then these are the system user events, and these are the corresponding workflows for those events. Now, when we are thinking about all these, the entire product life cycle or the purchase life cycle, we are at the back of our mind, we are thinking of different components, right? We thought about login, we thought about a product, we thought about inventory, we thought about the different notifications and so on, right? So these are little things that are coming to the back of our mind, and these things form components into our system. So that is the next activity we're going to do. We're going to identify the different components that are needed to build the system, right? So we talked about customer, we talked about product admin, warehouse admin as the different types of users. And to manage these users, we're going to need different modules, right? So let's say customer module will take care of the different customer flow, reset password, update username, and so on, those type of stuff, update profile picture and so on. And then product admin module will take care of onboarding a product admin, updating details, deleting a product admin, and so on. And similarly, warehouse admin, right? So these are the different components related to users. And then if we keep going, we have some more components. We talked about products being onboarded into the system. They can be updated, those details can be updated, so that can be taken care by this module. And then we have a cart module, which will take care of all the events that are happening when product is added to a cart, removed from cart, and so on. And then we have a payment module where customers can actually make payment. We have order module, which will come after a payment is successful, order is placed, which will notify the warehouse, and shipping has started, and so on. And then we have inventory module, which will take care of adding inventory, removing inventory, updating inventory, and so on. And then we have review module. This is for feedback. This is also part of our scope. adding a feedback, some star rating, some text-based description of feedback, and so on. And then we have login and registration, which will be taken care by the auth module. And finally, we have notification, which will be taken care by notification module. This will involve triggering emails, push notifications, or whatever. So these are the different components that I need to build the system for the scope that has been given to us, right? So this is one of the important steps while breaking down the system into different components. At this point of time, I still don't know whether I'm going to build this as a monolith, whether I'm going to build this as a purely decoupled microservice, or whether I'm going to do some kind of a hybrid. I just know that these are the components I need to build the system. So what do I do next? I'm going to identify architectural characteristics for each of these modules, right? So how do I do this? So for this, I'm going to make use of a tool called architecture characteristics worksheet, which can be downloaded from developer2architect.com. Again, this is part of the team that has been working on building all these software architecture related lessons and resources. So if you go to resources, you can just download these architecture characteristic worksheet and architectural styles worksheet. We're going to make use of these. So how this works is, let's say you are talking about a customer module, let's say. So we're going to identify the driving characteristics for customer module. Do we need performance? Do we need responsiveness? Do we need availability? Do we need fault tolerance? Do we need scalability, elasticity, and so on? There are so many characteristics like this, and the definitions of the characteristics are given here under the worksheet. So what we'll do is, for each module, let's say the customer module, I'm going to identify the applicable entities or the applicable architecture characteristics for this particular module, right? So for this one, I have identified these as my main characteristics because this is a customer module, customer facing application module. Performance will be key, availability will be key. As more users grow, scalability will be key. I want to be able to maintain this application code, and data integrity is something that I require for this application module, right? So it's not in any particular order. These are just the characteristics that are applicable to this particular module, right? So I'm going to go through this list and pick things that are relevant for this module, and then I'm going to just mark them here. Similarly, for product admin module, I'm going to need performance, availability, maintainability, data integrity. Similarly for warehouse admin. So these are simple CRUD operations, as you can imagine. So the characteristics are also quite similar in nature. And if we keep going forward, we'll see some differences. Let's say we have a product module. I want to have extensibility as a product module characteristics, because if we look at the definition of extensibility, the ease in which the system can be extended with additional features and functionality. I felt that for this particular product module, I want to be able to add different types of products in the future. I want to be able to have that extensibility option so that my scope is future ready, right? Something like that. So that's how I can identify different characteristics for different modules. I have cart module next. Cart module has performance, availability, data integrity, maintainability. And when it comes to payment module, we get some more characteristics. We need performance for sure, availability for sure, because these are again customer facing. But we also need elasticity and scalability, because as users grow, we want our payment module to be performing really well. And we're going to have some kind of elasticity needs, because there are going to be different events along the way, which can trigger more traffic, more bursts of traffic. So for this module, I'm expecting elasticity. I'm also expecting configurability, because I want to be able to support different payment methods. Today I may be having credit card and debit card. Tomorrow I will maybe want to add UPI or wallet based payment and so on. I want to be able to do that. And workflow becomes a key characteristic, because workflow is a key thing during a payment. There can be different steps involved while making a payment. So I felt workflow should be a key characteristic here. And then we have data abstraction, because one customer's payment should not affect another customer and so on. And then we have maintainability as a common thing. And similarly for order module, we have performance, availability, scalability, elasticity, data integrity, workflow, maintainability, quite similar to what we have in the payment module. And then if we go along, we have inventory module, performance, availability, maintainability, data integrity. This is simple CRUD kind of a module. And then we have shipping module, wherein workflow becomes really important along with data consistency, because shipping involves multiple steps. There is a key workflow involved. The product will be dispatched, it will be picked up by some delivery executive will be on the way, out for delivery, finally delivered, and so on. So along the way the data is actually traveling, so we'll need data consistency at all times. And then we have scalability and elasticity as well, very similar to order and payments, because more orders mean more shipping, right? And then we have review module. Review module has similar characteristics as earlier: performance, availability, maintainability, data integrity. And then we have auth module, where we have security as a main concern. So here if you see, security is given as implicit characteristic, but if it is a driving characteristic we can definitely put it here. And then we have availability, maintainability, data integrity. And finally notification module, for which I needed configurability, because I want to be able to configure different types of notification systems. For example, if I have an SMS system, I want to be able to onboard different types of vendors for sending out the SMS, let's say. And then extensibility, because I want to be able to support different types of notifications as well: today SMS, tomorrow email, and then push notification, and then something else, and so on, right? And then scalability, elasticity, because the more users starting to use the system, the more notifications will need to be sent, and some notifications will need to be sent on time, for example order tracking status. So scalability and elasticity become a driving characteristic here, followed by maintainability, of course, right? So this is how we identified the different characteristics. So there is some subjectivity involved here. It's not that whatever I'm choosing will be the main driving characteristics. So this exercise needs to be done within a team, along with the developers, testers, the client side stakeholders as well. So once you have these characteristics identified, what we'll do now is we'll put together similar characteristics together like this into quantas. So if I zoom out a bit, I think we'll see it better. Right. So we have user quanta, product quanta, order quanta, delivery quanta, notification quanta. So how did I come up with these? So all the similar characteristics like performance, availability, maintainability, I've put them together. So initially I had this whole set into one quanta, but then I broke them down into two quantas because they were looking independent. And all this side of things is related to user operations, and this side of things are related to product operations, right? So all the modules that we have identified earlier along with their characteristics, so I've picked the ones that are having similar characteristics. For example, all these modules: auth, customer, product admin, warehouse admin, product, cart, inventory, review, all of them had similar characteristics. So initially I had all of them in one quanta, but thinking about how closely related they are, what is the coupling, what is the cohesion between these modules, I made a break into two different quantas. So this is user quanta, which will take care of all user related operations, and this is product quanta, taking care of all product related operations. And similarly, I have order quanta, which has payment module and order module, because they were having similar characteristics: scalability, elasticity, performance. Delivery quanta, which has workflow, data consistency, scalability. Notification quanta, scalability, elasticity, configurability as the key characteristics. So let's say these are top three characteristics per quanta. And what is a quanta? Quanta is nothing but a grouping of all the different components that are having similar characteristics that can go together, right? So at this point of time, I just know what are my logical breakdowns, and I know which components in my system are to be grouped together, which components can be decoupled from each other, right? So after identifying all this, I can make use of the second worksheet, which is this one, architectural styles worksheet. So how we're going to use this sheet is we're going to mark the top three driving characteristics. For example, if I take order quanta, I have scalability, elasticity, and performance. So I'm going to mark this sheet like this for scalability, let's say, and then elasticity, let's say, and then we have performance, which is nothing but responsiveness. So at this point of time, we have these three as the top three driving factors for our quanta, and from here we can pick the best suited architecture style. For example, I can go with, let's say, 3 5 stars, which is space-based architecture. But if you think about it, the implementation can become quite complex if we talk about space-based architecture, and cost also is high. So instead of that, I can go for a microservices plus event-driven architecture style, because this quanta has multiple modules: payment module and order module. So depending on the payment status, order needs to be triggered and so on. So there is some kind of event coordination happening here. So for that reason, I'm able to choose microservices come event driven as my architectural style for this one. You can also go for space-based, arguing that you need these three characteristics. But as we know, the trade-off is implementation will become quite complex, and it is also costly because we have to maintain everything in RAM and so on. So if these are not your constraints, you can definitely suggest space-based architecture as well. But I'm going to go for microservices plus event-driven for the reasons I said before, right? Similarly, I have done the same exercise for different quantas, and after that I have my final list, which is nothing but user quanta is service based, product quanta is service based, order quanta is a hybrid, microservice plus event driven, delivery quanta is a microservice, notification quanta is also microservice, right? So if you think about these quantas, delivery and notification, they can have their own database, they can have their own workflow, and they're not really dependent on any other particular quanta, so they can live on their own. And user quanta and product quanta, they can also survive on their own, but they have multiple modules and all of them can share a single database. That's why it becomes a service based architecture for this quanta, right? So that's how we're going to derive architecture style, guys. If you have any doubts on the approach, definitely let me know. I know this is new, many of you may not be knowing about this structure, but this is what something that is recommended in the book, and it works really well for any type of scope. We can break down the system into logical components, and we'll see what are the components that are going well together, what are the things that can be decoupled, and we're going to identify the different characteristics, and based on those characteristics we can actually make a choice on architecture style, and we'll have a very good and valid reasoning behind the choice that we made, right? So that's all I had for this video, guys. I hope you learned something new, because this is something that is not discussed very often. Thank you so much for watching. If you have any doubts, definitely let me know. Please leave a like if you found this helpful. Please subscribe if you haven't done already. I'll see you in the next one. Cheers.